Hey there, in this video we're going to look at the possibilities for different numbers of x-intercepts for a quadratic function and how you can predict it directly from the vertex form equation. Let's do that now. Alright, so to predict the number of x-intercepts just by thinking quickly about the equation and the graph, we need to first think about in general about what the different possibilities are for how many x-intercepts. And then we can look at some specific functions in a second. All right, so if we think about it here, there's a few different situations we could have. Case number one, you might have a parabola where the vertex is above, but it opens down from there. Or say the vertex is below, and it opens up from there. And that either of those cases, you've got two x-intercepts. Two x-intercepts. Case number two, you've got the vertex on the axis and it opens up, or vertex on the axis and opens down. That's actually a case where you only have one x-intercept, just a single touch to the axis there. And then the third situation is, say the vertex is above here and it opens up, or the vertex is below and it opens down. That is a situation where you have zero x-intercepts. No x-intercepts. Right? So you either have 2 or 1 or 0. And you can just visualize the graph and think about the vertex form equation to make a decision on how many there are. If you think about the vertex form equation here, x minus h squared plus k, these two things tell you where the vertex are. So if you think about where the vertex is, that's a good start. And then this, you have to decide whether it opens up or down. So the decision you have to make here is, does it open up or down? And whether the vertex is above or below. If you think about it, this is the one that's going to affect whether it's above or below. Vertex above, below, or on the axis. Right? So there's actually three cases. It could be below, on, or above. Those two things together are going to make, you're going to be able to make the decision on how many x-intercepts there are. All right, so let's try a few specific examples here. So we've got this situation here. Now that actually, you have A is 0.8. That tells you that it opens up because it's positive, right? That is positive, so it opens up. And what does the value of k tell you? Minus 3 is the value of k. It is negative, means vertex is below. If the vertex is below but it opens up, then you have this situation. You're going to have two x-intercepts here, right? And how do you know? Because it opens up, vertex is below. In this second situation, the a value is negative, so it opens down. And the k value is positive, so it has a vertex that is above. So you have this situation here where you have the vertex above, but it opens down. That also has two x-intercepts. All right, moving on here. This situation here, you have the a value isn't written there, but it's a 1. It is a positive number. It opens up. The k value is that number outside. The k value is positive, so vertex is above here. Vertex above. If you're trying to think about what the graph looks like there, something like this, and it opens up from there, it actually has no x-intercepts. Right, because the vertex is above and it opens up. This one, the a value, that is actually an a value of negative 1. It's negative, which means it opens down. And the k value is also negative, which means the vertex is below. So if we have this, something like this, we have the vertex here somewhere and then it opens down from there. And you have then also no x-intercepts. Right, if we keep going here, a is positive, so it opens up. The k value is, there's no k value there, it is 0. The k value is 0 there, there's nothing, so it is on the axis. Okay, the vertex is on axis. And so you have something like this where it opens up from there. So it has 1. Now, you actually wouldn't even need to know which way it opens, because if it's on the axis, it doesn't matter whether it opens up or down. This last one here, a value is negative, so it opens down. And k value there as well is 0, so the vertex is on the axis. Right? It hasn't been shifted up or down. So it's opening down from there. That is not a very well drawn parabola, but you get the idea that it also has one x-intercept. Alright, so that's using the a and the k value. Incidentally, just so we realize here, it doesn't matter what the h value is, because all that would do is shift it side to side. It's not going to change how many x-intercepts it has, right? It's just a horizontal shift, and that doesn't affect anything. So that's a look at how you can think about the parameters in the vertex form equation and use the values of a and k to make a prediction about how many x-intercepts a quadratic function has.